Hi everyone, in this video clip, I will be discussing about Databricks Delta tables and its internal working mechanism. Let's get started. What are Databricks Delta tables? By the name, you can feel that they are like the tables of data warehouse. But then these are not the tables that we create on the database or in the data warehouse. These are in fact the tables that are created in the data lake. But how is it possible? Data lakes are meant for storing the files. But then, how do we bring upon table properties or features onto the data lake? So that's where the delta tables will be helping us. Though the data is stored in the data lake, though the data is in the form of the files, yet we can define tables for the data sitting in the files, and we can have all the table related properties associated with it. Fine. So in essence, the data will be stored in the data lake, and delta tables is kind of open source format which will help you build data warehouse like tables on top of the data sitting in your cloud object storage like AWS S3 or Azure Data Lake or the Google Cloud Storage. How is it, how is it done? Let us have quick look at uh, very basic information. When you go about executing create table statement behind the scenes on the file storage, the object store of the cloud, a folder will be created with the name of the file as you see here. And along with that, inside the folder, which will be having the same name as that of the table, there is going to be a subfolder with the name of underscore delta underscore log. Within that, a JSON file will be created. So this is what is powering the table features on the data lake. Whatever kind of operations we do with respect to the table, it will be tracked and maintained under this particular folder. Now, you see that nowhere we have any data. It's just the empty table that we have created. What if we load some data into the table? Maybe you will be using insert into, or you may be using copy into. Okay, and that way if you load the data into the table, it's nothing but the second kind of operation that we are doing on the table, which is about loading the data. So information about that operation is also listed over here in the form of creation of new JSON file. So this was created when we created the empty table, and this one is getting created when we are inserting data into the table. So that way all the operations that we do on the table are tracked. Apart from that, we are loading the data into the table, right? That data will be stored as compressed Parquet file directly under the people folder. Fine. So for delta tables, table data and its metadata operations have to be tracked, right? And they are maintained over here under the delta lake and the table name folder structure. So every data insertion creates a new Parquet file. Every table operation that we create is going to create the new JSON file in the underscore delta underscore log. So that was the brief intro onto our delta lakes. Let us understand it thoroughly, how these things are happening behind the scene. We should be able to uh, perform the insertion of the data, updation and deletion and all that. So as we do these operations under the hood, how the changes are happening, we will understand it. Fine, let's get started. I'm using Databricks Community Edition. To make for more room, I will be just minimizing the other tabs. My notebook is attached to the cluster. Here, since I have these files already, to avoid errors, I am Just clearing those files on the DBFS. Great. Next up, to understand delta tables and its features, let us try to understand what is problem with normal tables that we create on the data lake. For example, I have this file called people.csv with some information like what is the name of the person, some contact details, and so that data I have already hosted onto my DBFS. Using that, I'm creating a data frame, and later we will store this data frame as table. Let that happen, and in the very next cell you can see that the previously created data frame, we are trying to write it back as Parquet file format. Fine. And I'm also mentioning the location where this uh, file should be written, and I want to store it as a table. So this is how you can convert your data frames into Databricks tables. Fine. But behind the scene, data will be stored in the form of Parquet file. So with this, what happened? Let us try to understand it. Let us go and look at this particular location. This is where we are storing it, right? For that, let me head on to the catalog menu. I'm in the DBFS, and this is a folder which I have mentioned, and you could see within the data test by the name of the table there is a folder created, and you could see the data is stored in the form of the Parquet compressed Parquet file. Great. Fine. So this is a table, and we should get that listed. Okay, here also database tables. If we go and let us maybe refresh it, you could see that there is a table created people underscore Parquet. And further, if we uh, work on it, okay, here we should be able to see the data in that table. Sample data will be displayed. It's loading. It, fine. You could see the schema of the data and the sample data along with its types and all. It's coming over. So essentially, the data frame got converted to the table. So we have that. Here, let us try to execute describe history on top of the table. It says this is not supported. Describe history statement, we have it from Databricks, but it's not meant to be used against the normal tables. That's why it says it only supported for delta tables. What if I execute describe extended people Parquet? It gives me here the details of the table along with the column names, and here to which catalog it belongs, which database it belongs, what's the name of the table, and what's the type of the table and all. In our upcoming videos, we will look at maybe more of these details like what is the type of the table and all. Location is given. Fine. And moreover, very important, you have to observe here the provider is Parquet. Okay, we are not storing this table in Delta format. We are storing it in just the Parquet format. Fine. So that is a distinction that you should be noticing here. Next, the related command that we can use with the tables is describe detail. If you look at it, it gives the format of the data and the name of the table, where it is located, and here something called num files which says nothing. So here also we are not getting much of the meaningful information. Just hold on. The same set of statements we will execute against the delta tables later on, and you should be able to relate back onto what we are trying here. Fine. Cool. The table is there, and commonly, right, we go about maybe inserting data into the table or updating the data into the table. Let us see if we can perform update operation on the table. Update people Parquet, set gender equals to female, where gender equals to F. So if I try some update operation, it says update destination only supports delta sources, right? So first of all, for the update to happen, your table has to be delta table. But the table that we have created is not delta table. It is just normal table based on the Parquet format. So it doesn't happen. So these are the limitations of creating normal tables over the data lake, maybe using some optimized storage formats like Parquet and all. So, but then how do we go about creating the delta tables which are going to give us the features of relational database tables like ACID properties? That is, we should be able to uh, uh, you know perform any kind of inserts, updates, uh, okay, and consistency should be there. The operations have to be atomic, okay, they should be isolated, and whatever we do, that should be durable, right? And how do we go about maybe rolling back, right? We did something, but we don't want to commit it, okay, we would like to roll back our table to previous state, right? So we would like to maintain the different versions of the table. All that is possible through the delta tables. Delta tables are powered by open source storage format called delta lake. Fine. So that's why let's now go about looking at how does Databricks support creating the delta tables. First of all, here I'm just checking if the table is there with this name. I'm dropping it so that we don't get any conflict. Next, just like your SQL, right? You are creating the table. On top of it, you are also mentioning where you want the table data to be stored. Fine. At this location, we would like our data to be stored for this table, right? So let us check on it. I will create it. Fine. Immediately after creating this one, let us look at what will happen here in the file system. Catalog dbfs. I will go to the location which I have mentioned. So that is the people, right? You see here, just immediately after the table creation, there is one underscore delta underscore log folder created. And if you happen to navigate inside, you can find that there is one JSON file created. So in the form of JSON files, we are tracking the operations that we are performing on the delta tables. Fine. One second. Let us look at what is there. Uh, One second. In this location. Fine. Okay, this is where we have the delta log folder, right? Let me execute it. Programmatically, we are checking the contents of the file storage. Fine. So whatever we observed through the UI, we can programmatically fetch it and you can observe it over here. Next, let us particularly look at what is there inside this 0.json file. Let us scroll down, check here. Okay, this is something that we have committed on so and so time by so and so user ID and the username, and what's the kind of operation that we have performed. It is a create table operation that we have performed, right? So that way the information is stored in the JSON file. Okay, next let us perform few more operations. So this is where I have just taken the location, but I'm maintaining different notebooks so that it will be easy to check through, okay, different contents here. Very first operation is nothing but the table creation. Now if you want, you can check the describe history of the table, and you should be seeing that there is going to be one version of the table. So this is a version of the table which is starting from 0. It got created at this time, and the operation whatever we saw in the form of the JSON, right, it is properly given here. Okay, it is this operation which is resulting in 0th version of the table. Fine. Now let us insert data into the table. I'm using copy into. I have discussed about copy into in one of the video. You can check on the data test channel. Excuse. Fine. So copy into people. The location of the file and format of the data is CSV. There is a header present, and we would like to infer the schema as well. So I will just execute it. Let that happen. And meanwhile, let us head on to check the history also, but this operation has to complete. Fine. It says that 1000 rows are, inserted into the table. Let us now check the describe history. See here, you should see the second version as well. Version number 1 created at so and so time. It happened because of the copy into operation. Now, if you look at the contents of the file, right? Contents of this underscore data underscore log. Okay, you can refresh it, and you should be seeing that there are two JSON files now. Earlier it was just one JSON file, but now we do have one more. 0.json is there and 1.json is also there. And other thing that you have to notice here is that, let us refresh it. Okay, let me click on this people table from the DBFS. You could see now, up, after performing the copy into operation, along with the delta log folder, we do see now the Parquet file getting created. So whatever data we inserted is getting stored in the form of compressed Parquet file. So the storage format is same, but these are specialized tables because along with the data we are also tracking the operations we perform with respect to the data in the form of JSON files under the delta log. So this is nothing but our delta table. So delta tables will be having this specialized folder delta log, which was absent in our normal table. We just had data file only here. Fine, cool. Now let us explore few more details. Let us try to execute the describe extended statements and all. Earlier, what was the provider? Provider was Parquet, but this time if you check, the provider is Delta. Type of the table is though external again because we are mentioning the location, right? So this is a crucial point, right? The provider is Delta here, so it gives us time travel versioning, right, and ACID properties onto the tables that we are creating here. Next very important clause is the describe detail. Let us check through it. Here again it gives information about the table. So format of the table is delta. Every table has the ID. This is the ID of the table, name of the table, where it is located, and how many number of files are there. There is just one file, right? One file containing the data. That's what we checked earlier. There is just one file containing the data, uh, this one, right? So that is what listed over there. Fine. Even it will be listed here in the database tables. Now you can see people, right? Table is listed. Okay, fine. Let us just maybe, right, not worry about that sample data and all. Let us try to understand here the internals. Cool. So programmatically, if at all you would like to explore upon what's happening here, you can check through it. But I have taken these statements into the other notebook so that we are not doing uh, kind of the scroll up and scroll down thing, and let's not get confused here. So far we have two versions of the table. One is the empty table, the other one is the loaded table due to the copy into operation. Next what we do is let us insert few more records into the table. Let us say those records, I have it in the form of the view, and there is something written here. Let's not maybe worry about this merge into the merge into feature provided by Databricks. But essentially what's happening here is insert. So we are inserting these many records, 6 records into the table. You can see it, right? Merge into the people. So we are essentially inserting into the table. I will just execute it. And next up here, just to ensure that we have inserted, the starting number here is 999, 998. So let us check whether those records are inserted or not. See here, number of records inserted is 6, and let us verify that. Okay, the IDs are greater than 999, and we have the 6 records. With that, now if you check the DBFS, fine, file store, tables, and here the people folder, you can see that we have how many Parquet files? We have 7 of the Parquet files. One was because of copy into, and through the merge into, we are doing 6 inserts, right? 1, 2, 3, 4, 5, 6. For each insert operation, it's creating one Parquet file, right? We can check on these details by executing through that describe detail and all. Where is it? It's here, describe detail. If I execute it now, you'll be seeing that number of files here is 7. Fine, cool. So this is what I was mentioning in the introduction. Every operation that we do, specifically the data load operation, it will be resulting in creation of the Parquet file. Great. Okay, here quick check I am doing because we are about to perform now update operations. I'm checking here how many records are there where gender value is F. Let us just check it. And you are seeing that there are 1002 records where gender value is F. Let us update it. Instead of having the gender being F, I would like to have the column values as female. So update people set gender equals to female where gender equals to F, right? If I execute it, this time update happens because it's a delta table, not the normal Parquet based table it is, right? So number of rows affected is 1002. So it has updated. But what has happened to the number of files there? Earlier we had 7 files. Let us check through now how many files are there. So file store, tables, data is here, people, and how many files are there? Okay, 3, 4, 5, 6, 7, 8, 9, 10 files are there, right? So number of files is differing this time. Fine. But if you go to the describe detail, maybe let us execute it from the other notebook to avoid the confusion. I have it here, describe detail people. It is going to still say that the number of files is 7 only. The number of files is 7 only, it is stating. So what could be the reason for that? Fine. You can maybe further explore on this, what's happening here. Okay. If you look at the kind of values that we have inserted, there are okay, 2 records with F, right? There are 2 records with F, and that's where it was giving us number of records with gender being F is 1002. So initially whatever we had from the original people.csv file, the gender was F for all the columns, and on top of it, through the insert we added 2 more records where gender value is F, right? And now all those files should get updated, right? So in those original 7 files, one of the file has the 1000 records, and 2 of the files have this F value in the gender column. So those should be updated. So that's where one file will be written where 1000 rows are there and it is updated, and two more files are there, right, wherein the gender column was F, right? Even those should be updated, right? So that's where three new files are getting added. Three new files are getting added. So earlier it was seven, and now three more files got added. But the previous files are not deleted. But the previous files are not deleted. I hope you are understanding it, and you should be closely checking out yourself. Fine, these things. Okay, fine. Likewise, let us check through. Okay, how many records are there where the gender is M? Let me just check it over here. How many records are there with the gender being M? Earlier there were no records, right? Originally there were no records. Four records, and those were something that we inserted. Fine, you can see here among the six that we inserted, four of the records have the gender value being M, right? And corresponding to each insert, we have four Parquet files. So now, if I execute update, okay, update for these gender, which is something we are doing here, update people set gender equals to male where gender equals to M. Can you tell me the number of files that will be created after this operation? Let us check it. I will just execute this, let that complete, and after that we will go back and check the number of files on the dbfs, right? It says it is 4, and if I just write again and check, so you are seeing that lot many files are there. It is difficult to track from here. So what shall we do is let us switch to, okay, programmatically checking the number of files there. So which is nothing but the people folder, right? We have to get know the number of files in the people folder. So what shall we do? 1 second. Okay, it's here. Okay, percentile FSL is, you can check here the number of Parquet files that are present at this time. So 15 are there. Okay, 15 files are there. So this way you are observing that the things are changing. But then if you go and look at the, fine, here, describe people, describe detail people, the number of files still it says to be 7. So what are those additional files doing there? 8 additional files are there. What are they doing? Fine. So there are some stale files which are not required uh, to query the data for the latest version of the table, right? So that's where these unwanted files we should be removing. And for removing, we have something called uh, the vacuum and all. But before vacuum, maybe, right, we can try something like the maybe optimize. But now before we proceed on to it, you can check on how can you query against the different version of the table. Here I have the query for that, which is, let us say, a version as of 0. This is the syntax, syntactical things and all. Please refer to Databricks documentation. Fine. Let me execute it. So if I say select star from people version as of 0, there is nothing inside it, right? But if I say version as of 1, initially the people.csv had 1000 records. So it should be displaying me all those 1000 records over here. Fine. But if I say, or maybe, right, let me go for count. Easy to track up on that, right? It should be giving me 1000. But if I say version as of 2, that's nothing but after our merge operation, 6 more records were added. So I have it here as 1006. Fine. So this is how the things are happening in version as of 3, 4 and all, you should see the same number of ones. I will leave this for your practice. I can share across this notebook in the description. You can follow along. So this one you track it yourself. You execute it and see, okay, how the number of files are changed and all that. So as you observed, uh, we have 15 Parquet files. Fine. We don't want those files to be there because the describe details tells that 7 files are enough to query the table as of the current version. So we have to remove those unwanted files. For that, you can run this optimize people statement, and we will see what will happen after that. Okay, this optimize people is resulting in number of files being added is 1, number of files being removed is 7. So earlier I was mentioning that to query the current version of the table, 7 files are required. That's what the described detail also told us. But then the data was scattered across multiple files like this 7, and amount of the data is very less only. So there we have the small file problem. So over the data lake, having the too many of small files is also a problem because we have to track their metadata and all that. That's why we should be having the files with optimal size, which can boost the performance. That's where we are executing optimize there, so that the small chunks will be uh, put into larger file size, right? So now all of the data that is related to this table is available from the single file only, right? So with that, now if you look at the number of files in the people folder, one second, fine, let me just scroll it down, one second. Here, if you look at it, earlier 15 were there, now 16 are there because one more file was added, and it said that 7 files are removed, but the removal part is not happening immediately. These files are just marked for removal. They are enabled for deletion, but they are not deleted immediately. So this is the safety check we have with the delta tables and the supporting files. There is one more cool feature associated with optimization, that is a Z order. We will explore about it maybe in the upcoming videos. Okay, but this is how you use it. If you want, you can check it out. So now, so how do we get rid of those unwanted Parquet files? As of now, right, if you look at the number of files required for the current version, it will come out to be actually 1. If you go to describe detail here, describe detail, and if you execute it, it will just say that the number of Parquet files required for this version of the table is just 1. So other 15 files, right, we don't need them, but we may have to keep them around so that we should be able to do the version control, right? What if I want the data as of version 4, 3 and all, but we can't keep that infinitely, right? So that's where Databricks maintains the files for certain duration. It's going to keep the files for, one second, okay, 37 days, right? It's going to keep the files for 7 days by default. So that's where though it said the optimize is removing the files, they are not immediately removed because by default Databricks is going to keep those files for 7 days. Likewise, the log files also, the .json files also, they are not removed. By default they will be kept around for 30 days. But for our exploration purpose, let us check on how can we remove them, right? I don't want to keep them forever and ever. Even I don't want to keep them for 7 days or 30 days, right? That's where you have to disable it. Okay, the retention duration check dot enabled equals to false. So that is you are disabling that default behavior wherein Parquet files are kept for 7 days and your .json files are kept for 30 days, right? So that thing we are disabling it here. So let me execute it. And after that, okay, after disabling that check, we are also mentioning here we would like to keep around the files for 60 seconds only, right? After removing, right, we want them to be around for 60 seconds, not for 7 days. Likewise, you can set it for log retention. So these are the kind of global settings that we are doing at the Spark level, but you can set them at the table level also like this. Let me just execute them. And now to remove those files, you should be right, you should be executing the vacuum on the table, right? We know that they are unwanted files, right? And to remove those unwanted files, you have to execute the vacuum. But even if you execute the vacuum, those won't be deleted for 7 days and 30 days as I told. So to disable that, all that we did here, right? So after vacuum, we want the Parquet files to be disappearing after 60 seconds. So that is the deleted file retention duration. We are setting it to be 60 seconds. So what we are doing here, we are telling vacuum table retain 0 words. We are telling delete all the files of the table called people, okay, which are not relevant for the current version. Retain 0 hours is nothing but retain the files that are required for the current version only. That is the meaning here. Let us execute. So this is happening. It's taking a while. So once we are done with this, you can just visit that DBFS location and you can verify the number of Parquet files after 1 minute. Okay, you should be having only one, right? Let us see the describe history also now. So whatever we performed create table, copy into merge, and 2 times we did update, later we did optimize, right? So all that is recorded here, which is resulting in different version of the table. And let us check on the files also here, because vacuuming we did, and see here only one file is left out now. All those extra 15 files we deleted. Okay, so after executing your vacuum command, it will wait for 60 seconds and it will delete it. If you don't disable that, okay, which we did, it will be there for 7 days. These Parquet files will be around for 7 days, right? So with this, you are now equipped with, okay, how does the Delta Lake tables work in Databricks, which is very essential information to further, okay, deep dive into Databricks. Thanks a lot. Keep watching out for the new videos from our channel. Have a nice day.